Okay, I start.
Yes, Julian, please go ahead.
Okay.
Good morning, everyone.
So, welcome everybody. As commented by our colleague, the idea of this meeting, of this webinar, is that you understand a little better what we want to do in this project, and that you can make these applications more connected to what we are doing in the AMALTEA project. So these first slides are going to summarize a little what is the project and what are the main topics that we want to achieve during the 4 years that we are going to work in the AMALTEA project. So the main idea is to introduce robotics, artificial intelligence, and data in construction to reduce energy consumption, resource use, waste, and enhance safety and quality. And also, we have a big scope of the Green Deal objectives that at the end, this is something that we need to achieve at the end of the project. So the main key goals are reduce energy use, waste, reduce also defects to less than 1% during the different process. We also want to improve safety, efficiency, so 30% fewer hours in the activities that we are going to perform in the project. And obviously, sustainability is another key goal. The idea is to improve the way that we reuse recycling, the processes that we are going to follow during the project. We are going to validate the solutions in 4 European projects that pilots that later they are going to explain. And part of this process, and that's why we have this webinar, is that we want the help of small and medium companies in different elements of the process that we are going to follow. The main approach inside the construction process is to digitalize the curtain wall facade value chain. So facades, but inside facades, facades made with aluminum, glass, wood, industrialized, modular. And for these components, what we are going to develop, design, manufacturing, installation, on and disassembly recycling, using different digital tools and technical solutions. Next slide. The consortium covers all the parts of the value chains, from the design, digital solutions, robotics, manufacturing, construction, connection with humans, exploitation and dissemination, and open calls like the one that we are having here. We have 15 partners. The project is going to last 4 years until the 31 of December of 2028. And you have there the partners and the countries where we are. More or less, they are distributed across Europe. Next slide. This is an important graphic where we show all the activities that we are going to perform in the project. So you can see in the upper part the value chains of a facade curtain wall. And the idea is that based on the different challenges, we improve the architectural and the engineering design of these facades that are quite technological. Moreover, what we want is to improve the manufacturing process that they use now to manufacture these components. At this moment, it's quite manual. So the idea is to introduce robotics, automation, but also the elements that can improve the quality of the components that have been done during this process. Also, installation is going to be quite important. The installation is based on modular components, and our idea is to use robotics and different elements in order to make the installation of these modules with a little help of the human, but trying to improve the safety and the quality of this process. And inside all the process, what we want is to make different approaches in order to improve the way that we can reuse and recycle the different components. And some activities are going to be done related to this topic that are going to cover the entire value chains of the process. Next slide. So something that you need to have very clear, this is a little more technical, is how this challenge connect to the project. So we have 5 key principles in the projects. What we want to improve is flexibility, integration of the different components, collaboration across the entire value chains, improve sustainability, and obviously improve the innovation of the entire process. For that, to achieve these key principles, what we have done is to define 4 digital solutions: one digital solution for design, another for manufacturing, another for installation, and another for disassembly and recycling. And connected to these digital solutions, what we have is 8 challenges. That is the ones that you need to cover in this open call. Next slide. So the digital solutions related to design are the 3 first ones. So what we want is to use artificial intelligence to improve the design, automate simulations, have digital twin that can split or can distribute all the information across the value chains. For manufacturing, what we want is to improve the process of collaboration inside the activities, automatize the welding and the glass bonding of the activities that are done to manufacture these components, and improve the quality control of this entire process. For the installation, what we want is to use collaborative mobile robotics, as you have seen in the previous image, in order to automatize the installation of these facades. And for that, we need different sensors and components to allow the robots to realize where they are and how they are performing the different activities. And for disassembly and recycling, we have 2 digital tools that are related to how we can use this collaborative mobile robotic platform for uninstall the facades, and how we can use different strategies for material sorting and recycling. So more or less, this is the entire approach that we have in the project. And now what we are going to do is to explain you with a little more detail the challenge that you need to cover in your applications and the pilots that we are going to have later in the project. Next slide. So these are the titles of the challenge, and now we are going to have an explanation of each of them in a little more detail in order that you have more information than the one that we have in the first webinar. Next slide.
Hello, everyone. My name is Markus Renner. I'm Research Associate at the Institute for Computational Design and Construction at the University of Stuttgart, and I have the pleasure to start with the first challenge. So challenge 1 is about solving one of the most critical bottlenecks in digital facade design. So how to store and organize and share data consistently across all stages of the project. We're working with 3 key digital tools. The most important one, DT3, the extended digital twin. It's our central hub. It collects and organizes data from the entire facade lifecycle, so from early design all the way to recycling. This means we can keep one consistent flow of information and avoid losing track of important data. DT1, the AI-enhanced parametric design system, feeds this hub with standardized inputs, things like materials properties, environmental conditions, and manufacturing tolerances. So let's make sure that we start with the clean, structured data. DT2, the automated simulation tool, uses the same data to run reliable simulations and always stays updated when inputs change. In regard to the digital tools, the challenge will build a centralized data backbone that removes data silos and ensures that everyone works with the same up-to-date information. So this challenge will also should also deliver standardized communication protocols, meaning different tools, robots, and digital twins can speak the same language and exchange data smoothly. This leads to lifecycle traceability that can capture design, manufacturing, installation, and even recycling data in one place for better decision making and monitoring. At the start, the technology readiness, like TRL, should be around 3 to 4, meaning concepts and isolated data storage solutions, but limited interoperability, with limited interoperability. And by the end, we're expecting a TRL 6 to 7 where this integrated data backbone is fully validated and demonstrated in pilot environments. We encourage you to work with open formats such as IFC for BIM, JSON, XML for data exchange, and well-documented APIs to ensure interoperability. The data you will manage ranges from design parameters and simulation results to robotic process logs and recycling data. So you need to think about scalability and security as well. But in the summary, challenge one lays the foundation for a connected, standardized, and traceable digital workflow, allowing all consortium partners to collaborate more effectively and create a robust kind of digital twin of the facade system. Thank you.
Thank you, Mark. Okay, Rob, you're next. Thanks.
Thank you. Okay. I'm Robert Henderson, the founder and development director at Etc. And we are the designers on the project, and we're taking a rather unique approach to design in general in the project. And this is what Challenge 2 is related to. So the parametric solution generator for the AI training. The overall approach is that the facade design at the end of the project will be created through an AI model. So what is required? The digital solutions and tools for the project are based in design software, primarily Rhinoceros and the parametric software Grasshopper that fits within it. There will be other components that are required to be used, for instance, Python scripting, as well as various plugins that may help with the process, such as Ladybug. The option to be able to better calculate the iterations which are required is to use Visual Studio Code, using hops and Flask to connect to a backend server to do so may be required. And this is optional. This is about how the process will go forward, and we will see this as we move forward. But let's say your knowledge of Grasshopper, Rhinoceros, of course, and Python and related plugins will be required. So what is this part of the project sits in between a little bit what Marcus just described from Challenge 1 and what you will see in Challenge 3. You will be assisting in the further development of the automated workflow for which the methodology is currently being created. Right now, we're working with specific facade types of variables, U value, G value, etc., in order to build up this methodology. Now, the idea and a lot of what we will be asking for in this challenge is to help with flexibility, scalability, bringing in more background data, material properties, additional environmental properties as well, in order to improve the overall training of the surrogate models. And so in that way, you will collaborate a bit, let's say, with the design team, but then also with the artificial intelligence team who is maintaining the surrogate models. And part of the work will be to assist in the communication between those two parts of the project, adjusting on either side as necessary. So similar to the previous challenge, the technology readiness level starts at a 3 to a 4. That's where we are now, testing, creating a methodology, the first calculations, etc. But we should build up to a 6 to a 7, i.e. potentially ready for licensing, for instance, as a basic understanding of that, where the generator is then able to produce literally thousands of iterations that should be used for training the surrogate models. In general, then, the data that will be input, as you should be able to understand from what we've mentioned already, will be about having material property databases, restrictions from the robotic off-site manufacturing and the on-site installation, other parts of the project, as well as integrating the system data from the facade system itself, which is also being developed within the project. So just as a recap and to understand exactly very, very simply what is required is work with Rhino, Grasshopper, minimally Python scripting, as well as an understanding of how JSON files work and how they can be exported and used for surrogate model training. Thanks.
Thanks, Rob. Challenge 3, web-based graphical user interface for design decisions of platform-independent accessibility, is all about giving designers an easy interactive way to explore and compare facade design alternatives right in their browser. So your mission here is to create a platform-independent browser-based interface that allows users, designers, engineers, and these kind of decision makers to interact with the outputs of our parametric design and simulation workflows. So here are our digital, and here's how our digital tools work together. The first digital tool generates optimized facade alternatives and sends them straight to the GUI, where designers can explore them visually. The second digital tool feeds in simulation results. These are shown as Pareto fronts and parallel coordinates plots inside the graphic user interface. So users can see trade-offs between the cost, performance, and sustainability in a clear, interactive way. And the last digital tool, the extended digital twin, enriches the graphical user interface with real-time lifecycle data, helping users to make decisions with a full view of an environmental and economic impacts. One of the most innovative parts of this challenge is the integration of a retrieval augmented generation RAG system, which provides context-aware suggestions, relevant case studies, and guidance while users explore the designs, almost like an AI design assistant. And the expected impact is that you will provide a user-friendly, intuitive environment that accelerates the design process by reducing the time spent switching between tools. Designers will be able to make a better informed decisions by seeing all relevant data in one place, including aesthetics, thermal performance, costs, and so on, indicators. Starting with TLL 3 to 4, meaning an early GUI prototypes and initial RAG components, but they don't have to be connected to a real facade workflow. But by the end, we're aiming for TLL 6 to 7 with a full functional and validated web interface demonstrated in a relevant design environment. And you will use you should use web-friendly formats like JSON to keep data lightweight and responsive in the browser, with APIs connected to our digital tools. A key focus will be keeping the interface fast, even when working with large data sets. And in short, challenge 3 puts all the intelligence of our parametric design, simulations, and digital twins into one easy-to-use interface. And that empowers designers to make faster, smarter, and more sustainable decisions. Thank you.
Good morning. My name is Nerea Alberdi. I'm a researcher in Tecnalia, and I'm going to explain you the challenge 4. It's about the advanced inspection and control system for quality assessment in robotic manufacturing. So it's a bit different. This challenge is focused mainly in the manufacturer digital solution, and it's going to be in the manufacturing part. So the idea is to integrate a 3D vision system in the robotic system to implement the inspection of both processes, the welding process and the sealing process that is going to be the manufacturing part to the facades. So the digital tools connected are the automatic welding system and the glass bonding and the quality control of the facade manufacturing. The expected contributions here are mainly 3. The first one is to develop a 3D intelligent vision system that will be able to detect different types of defects and anomalies that will happen in the welding process and the sealing process. There are two very different processes from the point of view of the vision systems, but it's going to be a challenge. And we are going to use AI algorithms to identify these type of defects. The idea is to learn generic features of this type of defects and be able to detect the anomalies that we are not that we haven't seen before. So these features and anomalies going to be from the geometry of the welding part, the welding, or the sealing, the texture, or whatever. We have to detect the discontinuity, holes, the thickness, and different type of features. So this 3D vision system with its AI algorithms will be integrated in the robot control system. The idea is to detect the defects of the process as soon as possible to stop the process or to send an alarm to the user telling that the process is not going to be well, to don't waste time and to repair as soon as possible the processes. So the TRL starting level, I think it could be the system validation in laboratory, and the final have to be a system that can recognize a wider range of irregularities demonstrated in the payload case. The data format that we are going to be used mostly are going to be point clouds and meshes that the 3D system type of data captures. The geometry of the surface we are working with. Maybe CAD models that represent the facade structure, and then the process params, the different process parameters, the welding silicon, and also the connection with the robot joints and TC poses. Thank you.
Hello. So my name is Renzo Assam. I'm an IT consultant and researcher at Siemens. I'm gonna explain a little bit about the challenge 5 that's connected to adaptive manufacturing and quality control. So basically this is related to trying to change what we are doing right now. It's more an offline trajectory planning, and we want to do with this challenge and real-time online trajectory planning to be used in the robotic system. This is connected to the different digital tools like AI for manufacturing process optimizations, meaning that we will use a sensor and a computer vision to leverage an AI system to detect the points where, for example, the robotic arm have to go, and then derive how to create a trajectory planning, for example, for welding or for a silicon appliance. That's why it's also connected to the other digital tools like automated welding system and the automated grasp bonding, since it should do an unsupervised trajectory planning and also quality assessment when the process is running. With this, we expect that we increase the speed of this process that we will do otherwise offline, and it will also increase the quality for the facade manufacturing involved in welding and precision glass bonding. We'll start with like the other challenges with TRL 3 and 4, meaning that there's a proof of concept and there's some validation in a laboratory at the beginning, and at the end of this challenge, we will test everything in with the real robotic system and the real environment, and also with real processes like welding and silicon appliance. And for data types, there are going to be a lot of use different data formats, data types, but this is still to be discussed at the beginning of the challenge. But basically, the most important are the welding parameters, the silicon parameters, and you will also get some information about robotic joint states and TCP poses. And we also envision to use a ROS2 framework for the whole programming and communication between the many components of the system, and also using interfaces like REST for connecting to the digital twin of the or other external processes applications in this project. Thank you.
Hello, I'm Eduardo Chamorro, a researcher at Tecnalia. And here we are presenting the challenge number 6, that is advanced sensor integration for precise positioning and mobile robot applications. The idea of these challenges in the overall is to generate a basic and workable data set for the point cloud that scans through the scanning of the environment. Usually the major characteristics in these situations is the merging of the different point clouds and from the different sensors with proper authority without having a lot of gradual accumulation of the drift. What we are looking for is a sensor fusion middleware that integrates all these point cloud into a colored point cloud from the multiple 3D lidars, EMUR, and odometry from the AGV platform that we plan to use for this set of tasks. The pipeline, or actually what the actual status of technology is, there is a lot of drift in the point cloud for, sensor fusion merging that makes challenging to actually have a live integration of this point cloud. It's actually relatively developed technology, having it steady, but in the mobile, while the platform is moving, is what we are looking for. To address this, what is planned is to have segmentation of the point cloud in order to allow a high object detection in order to reduce the drift. What we are expecting is a final outcome of a repeatable algorithm that can self-calibrate itself, allowing to reduce this sub-centimeter accuracy. The stack in which one we prevent this to be implemented is, of course, ROS and different configuration files that you need for this point cloud, merging a total message that we plan as an output. As well, we are presenting challenge number 7. Please, next slide. Yeah. That is the position of the robot platform and the navigation with the collision detection. In this case, it's one step further. So challenge number 6 is setting a little bit the base for this challenge. That is to deliver a ROS2 package for the 3D localization and the SLAM navigation on this point cloud that is going to be done by the AGV platform. The idea is to have a 3D environment in which we can navigate and detect objects even in non-GPS or GPS denied operations. So it should have a UTM conversion to have a global free mentoring of the navigation framework. The idea is to provide as well a human interface that allows to path plan the autonomy of this AGV platform with collision prevention in order to avoid objects that are being recognized by segmentation on this already set point cloud of the environment. The idea of this challenge is to start from challenge from TLR 3 and to 4, where there is actually a SLAM sensor fusion with lock closure of the navigation to have relocalization. To arrive to a expected TLR 5, where actually we can meet a sub-centimeter plus minus 5 millimeter of total reference positioning on live navigation on this site that has been previously scanned. As well, the stack, in order we will want to have this challenge to be made of, is ROS environment with the proper docs and the navigation layers and the occupancy maps and distant fields of the path plan and of the platform. Thank you.
Okay, and the last challenge is related to how we can enhance the life cycle and the cost assessment using artificial intelligence and smart data. So the digital tools that are connected to this challenge are the one related to the digital twin. So at the end, what we want is to share all this information across the entire process to be able to use data in different moments of the project and check if there is any problem with the decisions that is being taken during that part of the process. Also, what we want is to be able to improve the quality control of the system, so how the manufacturing process can be improved, use this accurate inspection, and also check that the decisions that has been taken during the manufacturing process at the end are connected to the sustainability of the entire process. To do that also can be important or interesting to have real-time measurements during the installation and the operation. So at the end, what is going to happen on site sometimes have a big impact in what is being considered as the entire process. So what we want is also to check what is happening during this part of the process to see that, okay, we don't have anything that goes toward our main objectives. And what we commented about advanced sorting system, Tecnalia has a system that the name is Tracia that is able to classify different typologies of data, obtain measurements of their status and their characteristics to use this data to check that if the systems are good for recycling, they are better for reuse, so to try to improve or automatize the decision making that we have at this part of this process. So if you apply to this challenge, what we want is to have an holistic LCA, LCC across the entire value chains. The idea is to try to connect the different phases and use the information in a semi-automatic way to be able to take decisions and have warnings during the different process. The idea is also to use data from the pilots that we are going to see now and how we can consolidate this information into something interesting for sustainability and cost analysis. And the idea also to use artificial intelligence is to don't have only Excels with numbers, so static information, but also that at the end can request you to perform some activities in order to use this information and improve the decision-making process that is being taken during the entire value chain activities. Here we have a starting TRL a little higher than the other challenge, so at the end we can start in a 5, validated in lab environment. So at the end, what are these technologies being used, how we can use this information. There are some activities that can be used now in the market, and our idea is to finish with a TRL 7 so that we can demonstrate in the pilots that we have, in the 4 pilots that we have, that these tools can be used and we obtain interesting information related to sustainability and cost assessment. So the type of data is quite open, so we can use different source information from material properties, energy, cost, operational data, restriction. So at the end, what we want to avoid is fragmented data set. There are a lot of information about sustainability, but sometimes it's not well connected, and some harmonization is required during the entire process in order to have data that can be used in the different elements that we have in the project. And the formats where we are going to use later, as you have seen in the other challenge, Rhino is going to be something interesting. Being compatible models is also something that we are going to use a lot. And sensor data streams and structured database is also something interesting. And the idea is that we connect this digital or this challenge with the consortium tools, so the digital twin, the artificial intelligence models, and the robotic platforms to improve the interoperability of the entire process. So now, next, we are going to give you an explanation in more detail about the different pilots that we are going to perform in the project.
Okay, thank you, Julian. Okay, let's look at our first pilot case, the AI parametric design and extended digital twin with all the data workflows. This is where we bring AMALTEA's digital design solutions together and test them in a digital or realistic workflow. So this pilot focuses on validating our digital tools in a design phase and ensuring the work together as one connected ecosystem. We are combining 3 key components. So the first digital tool, AI enhanced parametric design system, which is our engine for generating facade design alternatives. So it optimizes material choice, panel geometry, and layout based on multiple criteria, such as energy efficiency, cost, environmental impact, and occupant comfort. The automated simulation for facade components, the tool, um, is about like is in the context of designs that are generated and the performance of this, or it's about like it's about the designs that are generated are simulated to compute the performance out of it. So DT2, so to say, runs thermal, mechanical, and sustainability simulations automatically, giving us reliable performance data for every alternative. And the extended digital twin is the central backbone. It keeps track of the entire facade lifecycle from design to manufacturing, installation, and even recycling, and make sure that all partners work with the same data. Well, where are we right now? We are currently building up the foundation for AI-driven design workflows, meaning we started by collecting material performance data, such as material of the profiles like aluminium and facade dimensions. And these parameters are input to our parametric facade model that can generate different facade panel variations. Using DT2, we run thermal simulations of the U and G value to evaluate the performance. From there, we perform sampling of many design variations to train a surrogate model. Trained surrogate model is much faster than the computational expensive simulations. And so finally, we use multi-objective optimization to balance all criteria, energy, cost, and comfort, and find the best solutions on the Pareto front. Next slide, please. So let's zoom out and see how all these pieces fit together. The old workflow puts DT through the digital twin right at the center. This is where all the data comes together, making sure nothing gets lost between the tools. So challenge one is in between creating a data storage and standardization framework, so that the parametric model, simulation, robotic systems can all exchange data consistently. Challenge two is where the design generation and optimization happen, corresponding to the parametric model simulations, but also additional metadata. The last challenge three, in this diagram, connects it all to the user. So through a web-based graphical user interface, where user can explore Pareto fronts and compare design solutions, and even get AI-based recommendations through a RAG system. Next slide, please. So what do we expect to achieve with this pilot? So from the three challenges, we expect that challenge one is a unified data standard is a unified data standard in a scalable centralized repository that ensures smooth data flow across tools and partners. Challenge two, a parametric solution generator that can automatically sample design alternatives suitable for surrogate model training. And challenge three, a web-based user-friendly interface where designers can explore solutions visually, compare trade-offs, and make informed decisions. We're starting at tier 4. We have separate research tools such as the parametric model, some simulation scripts, and basic digital twin prototypes. The goal of TL6 is by the end of this pilot will be to have a fully integrated and validated workflow, so data exchange protocols, connected design and simulation tools, and the GUI that has been tested with other real users. The format of the information to be provided at the end of the activity includes the prototypes, so such as cross-sector, data storage and exchange framework, AI parametric design platform, and web-based decision-making GUI. The process and algorithms with full documentation, APIs, and data workflows using IFC, JSON, XML, or YAML formats. And finally, the reports and datasets includes metadata datasets, performance metrics, such as time saved and user validation reports. And last but not least, the outcome of pilot 1 is more than just a demonstration. We aim to have a working, reproducible digital workflow that can be used by industry partners, tested in real scenarios, and scaled up for future facade projects. Thank you.
Thanks. So for pilot 2, that's the next step. After the design is the manufacturing of the facade that we are planning to do in the FDV facility in Hungary. So basically, how it's done right now, mostly for facade manufacturing, is that it's a very manual process where there are workers who are binding all the profiles of the facade and putting the glass and doing the inspection, checking if there's errors. And the idea in this pilot is to automate some of these steps. There's 3 main steps to be automated exactly. The first one is the welding operations. Normally, for facade manufacturing, we use screwing, but in this pilot, we want to use another type of joint, a welding joint, to prove the recyclability of the facade. And we also envision this using a automated robotic system. The next main process is the glass bonding. Oh, can you go back the one slide? Yeah. The second process is the sealing of the bonding of the glass with the facade, where you use a silicon appliance between the glass and the profiles. And then which is also another process that we want to automatize. And then the third process is the quality control that we also want to use a sensor, also explained like in chapter 4, a sensor to check the errors and check if there's something that it could be improved or not. This is a very collaborative process since we don't want to automatize the whole line. We also want to include the workers in the process. So that's why you also see in the picture that there are some parts where it is like a gantry system or robotic system where it's doing the operations, but there's also parts like putting some accessories or assembling the profiles at the beginning that they still will use workers. Yeah, the next slide. Good, and for this, we also see some of the challenges that we already described before. The challenge 1 and 2, that's mostly, and also the 3 actually, it's mostly linked with the design of the facade, but this all should also take into account the whole manufacturing processes into it, especially for the challenge 2, where they have to generate data sets. It also should take into account the assembly processes or the whole, what is feasible also in the manufacturing processes. Then challenge 4 and 5, it's, I think, the main challenges to be tackled in this pilot 2 about the adaptive manufacturing and the AI-driven quality inspection, since we want to improve what we do right now with a more online real-time trajectory planning, and also with a better quality inspection AI model. And of course, the challenge 8, since for the cost and environmental assessment also takes into account the manufacturing processes into it. The next slide. Thanks. And this tutorial level at the beginning will be 4 and 5, since this is some solutions that will be first tested in a laboratory environment, but not yet tested in a production line. And at the end of this pilot, it will be validated in the FDV facility in Hungary with the whole automated welding and silicon appliance and quality control. And at the end of the activity, some of the results or formal information that will be provided, and also the prototypes that will be given is we will also build a whole country robotic system for this pilot. We'll have automated welding and silicon appliance systems. We will have an AI-based manufacturing process optimization and also some AI quality inspection systems and control systems to improve the whole process, automate also the whole process. Yep, thanks.
Hi everyone, this is Álvaro Flores from Robimática. We are leading the work package associated to the robotic installation of the facade panels, and I will present you the pilots 3 and 4. These are the pilots related to the actual buildings. We are coming from the design, manufacturing, and there we are delving into the actual buildings. So the benefits of these pilots is quite simple. We will have real buildings to test and validate the solutions that we will be developing within the project and also within the open calls, of course. So we will have 2 pilot cases. I will describe them on an overview, the structure of both of them, because they are quite similar, complementary, I would say. So we will have this first pilot 3 that we are seeing on the slides, which is in the South Europe pilot case building, mostly related to hospital or residential typology. And in the pilot 4, I will describe Central Europe pilot case. It would be mostly related to office and residential also. So by means of the specific buildings that are yet to be defined, we will have them more advanced on the project, but we will count on them. We will have this pilot 3 provided by Acciona and pilot 4 by Sublin, which are both partners in the project. So the structure I will follow in both pilot cases, we will describe a bit the pilot itself, the challenge associated, then we will talk about TRL levels and what are the expected outcomes or the format of those expected outcomes by that means. So these 2 pilot cases also are mostly focused on the design, the installation, also disassembly and recycling. So you will see that the challenge that are addressed on those 2 slides are mostly related to that phases. So having said that, let's get into this pilot 3. Here we are talking about hospital and residential typology of buildings. Of course, in curtain walls and the kind of panels, facade panels that we are aiming in the whole project. But there are some specific conditions in difference between pilot 3 and pilot 4. So we can see there prioritizing hygiene, sustainability, the installation skills. There will be some tweaks in the pilot 4 we will see after all. And the specifics for the challenge that we have already seen today. In terms of challenge 1, we are aiming here to demonstrate the integration of the data from the installation and operation into the unified platform. In challenge 2 for the parametric solution generator, the linking of that generated data sets, geometry and material performance, having an accurate facade models for testing and in real context. In challenge 3 for the web-based graphic user interface, again, intuitive browser-based tools to explore and compare the facade design options. And then challenge 6 and 7 are mostly related to that robotic installation, both in positioning and navigation. How are we gonna do all those testings? How is the robotic procedure gonna work in the project? We are also inside the project working on all that, and you got to know the actual challenge that will be tackled in 6 and 7. And in terms of recycling or the whole sustainability of the project, it will be challenge 8 with the real world environmentally and cost data that will be provided by these pilots. Next slide, please. Getting into the TRLs, they will be mostly the same in 3 and 4. And of course, there are the ones from the challenges, starting from TRLs 4, 5, having tested some ideas, having the actual solution on a lab scale and getting it forward due to the pilot themselves to TRL 6.7s, being able to validate in a relevant environment. And for the kind of format of the information that we are expecting, you can see there, of course, it will depend on the actual type of call or proposal that you suggest, but it will range from prototypes to processes and algorithms, and of course, as always, some reports, deliverables, and data sets from when needed. Next slide. Here we have the Central Europe use case already described. Also, this will be tackling office and residential typology. Here that we are normally looking for another kind of things, natural lighting, the aesthetics is quite important in this kind of buildings. The materials are mostly the same. Of course, we are also having glass, aluminum, composite panels. And in terms of the challenge, I will leave you. I'm not gonna read again the whole challenges, but there are some small tweaks depending on the kind of building, but they are, as said before, are complementary in order to enrich the kind of environment where we can test and design all these solutions. So next slide, please. Getting again into the TRLs, almost the same. There are some specific difference here. For example, we're thinking more about robotic navigation rather than coordination that was before and control, but it's mostly the same in terms of having already, the look here is to having already some solution validated on a small scale and wanting to take them forward to a TRL 6.7, and the kind of information required will be almost the same. So that will be all. Thank you.
Okay, thank you, Alvaro, and thank you to all the partners for doing this great recap of the challenges with a direct connection to the digital tools that are employed by the project consortium to assist the third parties, the SMEs and startups that we are going to select in developing and validating their solutions within AMALTEA ecosystem. We are continuing the session. By the way, I'm Anka. I'm a project manager with Funding Boards, and we are the ones behind the screen with the application form, the help desk, together with my colleague Agnieszka. We are the ones trying to address all your questions, and hopefully we can tackle some of them today. So for the open call, for the first open call, you might have seen already, we call it Call for Solution for Facade Applications, because this is the focus that we have taken in the construction sector. And we are looking for solutions from innovators, from SMEs and startups, both for software and hardware applications. We are funding in this first open call up to 10 selected SMEs, selected projects, and they are divided estimatively between 5 projects for software applications and 5 projects for hardware. Each of these funding tracks, each of these financial instruments has limited funding of up to 100,000 euros for software solutions and up to 200,000 euros for hardware solutions. In total, we have allocated 1.5 million euros out of the 4 million euros for FSTP from the budget of AMALTEA for this first open call. We've just launched at the beginning of the month, and the call will be open until the 7th of November, which gives you plenty of time to go through the documentation, through the videos that we have, recordings we have produced during the Info Day and today. And we look forward to your applications and your questions today, because we consider that this is a great opportunity for small businesses to get not only the funding for sustaining their initial technology in initial stages, but also to get a full package from the mentors and all the experts in AMALTEA project. Next slide, please. I've already mentioned some dates. So we started on the 1st of September. We've already had the info day before that, and we are going to have, in addition to this webinar today, another one on the 16th of October. So if you are just getting familiarized with AMALTEA and you have questions between now and the deadline, you still have another chance to see us and reach through us, not only through the help desk, but also in these events. After the deadline, we are taking around 3 to 4 months for evaluation and sub-grant agreement preparation. And the evaluation stage includes also a jury day. So pre-selected applicants will be invited to pitch their proposals. It's important that you know that, because you can write everything in the proposal right now and it could look wonderful on paper, but if you get selected, you'll have to tell us about the ideas behind and the people behind the words. So the selected applicants we estimate are going to start the support program around the 1st of March next year. And for the software solutions, they will be with us for 9 months. Yes, and for the hardware solution for 12 months, 3 months longer. Next slide. We have very strict eligibility criteria when it comes to the type of applicants. So you would have to be an SME or a startup registered in one of the European Union member states or associated countries to Horizon Europe. We are looking at profiles, but this is the type of profiles that we could think of. It's not a closed list like digital, AI, robotics, tech providers for FATE value chain. You can be connected to the construction sector as long as your technology is addressing one of our challenges and has applicability within AMALTEA ecosystem. My partners have talked about the TRL that we are looking for as entry level, which is at the application stage. Your technology should already be at the minimum experimental proof of concept. Another condition is that for-profit entities have to provide at least 30% of co-financing. You'll see that a bit later in my slides when we talk about the budget, how it applies. If you are doubting whether you are a for-profit or not for-profit, I guess the simplest way to look at it is if you're sharing dividends at the end of the year, you're a for-profit. So you would have to co-finance the 30%. We are not accepting proposals. You can apply, of course, but you are not going to pass on to the next stages. Consortia, teams, subcontractors forming a team, universities, European digital innovation hubs. You would have to be registered as a legal entity as the date of presenting the proposals, and you cannot be affiliated in any way to AMALTEA partners. Next slide, please. I've already mentioned we are looking to select 10 best projects out of the proposals that we are receiving. So in addition to the funding, which is again 100,000 euros for software, 200,000 euros for hardware, the mentoring program is one of the greatest benefits for a startup or a small company which doesn't have the day-to-day routine of doing a business plan, of doing an individual planning, and this helps them greatly in achieving the goals of the proposals that they present here. Additionally, the solutions will be validated in 4 large-scale pilots. You've heard about them, the 3 physicals, a physical and 1 digital pilot, and this gives them, the applicants, the beneficiaries, an opportunity to validate in real-world circumstances, and this gives you the chance to get ready for the market. We are looking for solutions that align with one of the 8 challenges that you've heard about right now. You correctly identify your funding track, the funding instrument, the description of your proposal, the descriptive part of your proposal, clearly reflects that you are starting from a TRL 3 to 5 and you have a path by the end of the project, 9 or 12 months, to get to TRL 6 or 7. Compatibility with AMALTEA digital tools. In this presentation, you have it laid very clearly, like this is challenge 1. These are the digital tools that apply to this challenge. So do go back to all this information when you fill in your application form, because everything is here. You have to demonstrate a plan for pilot integration as well, and you have to make the connection to the European dimension, because AMALTEA is aligned to the European Green Deal objectives. In other sections, you'll have the chance to tell us more about scalability, market need, measurable environmental and societal impacts. Some of the eligibility and ground rules, but you'll have more extensive information on that in the guide for applicants. Of course, you'll have to submit before the deadline, and we only receive applications online. English is the working language for all EU-funded projects. You have to be very specific about the work being original and clear about the IPR rights. We are not asking at this stage from the applicants to submit any registration documents or financial statements. However, if you get selected, you are going to be verified from a legal and formal perspective as well. And this means that you may get as far as the signing of the sub-grant agreement, but when we ask the financial statements, if we don't find healthy finances or a situation of bankruptcy, if we find a situation of bankruptcy, then your effort would be in vain. We do accept multiple submissions from the same entity, from the same SME or startup, up to 3 distinct challenges, and only the highest scored one will be funded. This doesn't mean three times more the money, but it means 3 times more the chances for you. So you get funded once, but you have a chance to select 3 different challenges and present 3 proposals by the same entity. Conflicts of interest are also checked throughout the formal check, and if you know you are in a potential conflict of interest, better to check it with us right now, and we'll see what is the status before you commit yourself to submitting the proposal. Next slide, please. The evaluation and selection will run in 5 stages. I've mentioned briefly the jury day, which is the final stage, but before that, all submitted proposals in due time through the application form online will be submitted to an initial review, an eligibility check, and this is done based on your self-declaration, the declaration of honor that you will have at the end of the application form. The in and out of scope will be done by the selection committee, which is made up of technical partners from AMALTEA Consortium, and they want to see that you understood what we're looking for and that you are aligning your technical solution, your proposal, to the scope of the project. Once these 2 stages are positively passed, we are going to engage external evaluators. They are external, that is, means independent from the AMALTEA Consortium, and they are going to perform the independent evaluation based on the criteria of excellence, impact, and implementation. These 3 fields are exactly as such as you see them in the guide for applicants as evaluation criteria. You find them in the application form as well. So make sure you have the guide open when you write these sections and you understand what we are looking for. The scoring will be done between 0 and 5, and we have a threshold for individual criterion of 3 or above, and the total threshold is more than 10 or 10. All proposals that have scored 10 or above will be then shortlisted, and the selection committee again will meet in a consensus meeting to decide on the proposals to be invited to the jury day. We usually select twice the number of final beneficiaries that we are targeting. In this case would be 20 shortlisted applicants to be invited to the jury day. And out of those, 10 will be the final beneficiaries of AMALTEA First Open Call. We are communicating the results at each stage, so irrespective of the outcome, you are going to know where you are in the evaluation process. the support, the sub-grant agreement and the support program will follow the evaluation process. So for the funding rate, I mentioned the co-financing of 30%, which means that for profit, we are funding at 70%, and for non-profits, 100%. And both these are capped for software to 100,000 euros and for hardware to 200,000 euros. We are doing the lump sum mechanism, which, if it's something new for you, means that you do not need to submit timesheets, contracts, invoices in order to get reimbursed. We have stages of execution, as you can see here, for each of the software, each of the two financial instruments, and we are paying against deliverables and KPIs. This means that at the first stage, you are going to fill in an individual mentoring plan together with your assigned mentor. And if this individual mentoring plan is validated and approved by the selection committee, you are getting the first tranche of money, and so on for the second and the third stage, which comes with their own deliverables. So after the 9 months, you'll be getting the 100,000 euros or up to 200,000 euros for the 12-month support program. Just to make the process maybe more familiar for you, we prepared a few slides where we'd like you to get accustomed to the application form itself. So as you will see here, we have supporting documents for each stage of the process. The application form includes several fields. The last 4, I would say, 4 of them are just ticking boxes, so it's not as long as it looks here. It's the excellence, impact, implementation, and strategic fit with AMALTEA that you want to focus on. And for that, you have the guide for applicants to understand the project, the eligibility conditions. We even included some ideal project examples for you to relate to and see if your idea is around the ideal project that we conceived. And the technical guidelines are of utmost importance, because there you'll find even more information about the pilots and the challenges fully described for you to understand. I'm sorry, I have 70 challenges here. There are actually 8, as you've seen before. Next slide, please. So for the submission stages, first, please check the guide for applicants and the technical guidelines. On the OnePass platform hosted by Fundingbox, you will have the guide for applicants and the technical guidelines for you to open, download if you need to, and then you proceed to registering, signing up if you don't have an account yet on the Fundingbox platform, or just sign in, log in if you have one. Make sure that after you have submitted the application, not only you are getting a submission message on the portal, but you are receiving an email confirming that your application was submitted. Even if you submit it, you can edit it as many times as you want before the deadline on the 7th of November. And again, you can submit 3 applications per entity as long as there are different challenges addressed in each. Okay, next slide, please. So the application form, once you have registered and entered the OnePass from Fundingbox, you will have to fill in the mandatory fields. Pay attention to the ones marked with red asterisks, because those are mandatory and you cannot leave them empty. An update to our previous platform, for those of you who are familiar with it, we do have the option to save the draft right now, even if you don't fill in the mandatory fields, or you can just click next and the information will be saved automatically. You also have the option to add a collaborator to the proposal. So at any time, anyone who is in your team can enter the platform and fill in the application form. Next slide, please, before the deadline, of course. Okay, for the basic information, here you will have the option, and I want to insist on this one because we have spotted some confusions in some of the drafts or submitted applications. So you have the funding instrument that you have to select from, and you have the first funding instrument, which is software solution, or the second one, which is hardware solution. When selecting this, you have to go back to the guide or to the technical guidelines if you're not clear about it yet, and see if the challenge actually falls under the funding instrument that you have selected. Okay, so for software solutions, you have challenges 1, 2, and I believe 4 and 8, or 1, 2, 3 and 8. You'll find it in the technical guidelines. And the hardware hardware challenges are the other 4. So don't make this confusion to select a funding instrument that is not aligned to the challenge. TRL, we expect here to see 3 or above, but if you select less, that's you being honest, which we appreciate, but also ineligible. Next slide, please. For the implementation part, we had some questions where or how the for-profit entities have to demonstrate their co-financing capacity. This is the section where you explain how you are going to co-finance. We are not going to ask for any other documents or bank statements or anything for you to validate your co-financing, but you have to be very clear and coherent in this section, implementation, resources committed, how you are going to compensate for the 30% of your total budget. And it can also be in-kind contribution. So if you have a team allocating resources to this project for 70% of their time or more, and you are only computing for the funding 50% of the in-kind, difference can be considered co-financing. Remember to download the template for the Gantt and only fill in the one specific to your funding instrument, software or hardware, and then upload it again. You can save the draft for next and go on to the next slide, in my case, next section in yours. The budget is calculated automatically in some fields. So once you fill in the cost for personnel and the travels, pay attention that we estimate between 2 and 4 travels. So make sure that you correctly align the budget with the Gantt and everything else in the proposal. You will have a total, and I took these 2 examples here for you to understand how we calculate co-financing. And this is actually the only part of the application form where the financial instrument that you selected in the first field is reflected here. So other than that, you have to pay attention yourself to correlate the financial instrument to the challenges and everything else. So here, for example, with a test application where the total budget that is 122,000 euros, which is perfectly fine. If I select that I'm a not-for-profit startup or SME and I get 100% of my total budget, it will be capped to 100,000 euros because it's the software instrument that I chose, right? With the same total budget, if I'm a for-profit startup or SME, I only get 70% of the 122,000 euros, which means my requested financial support is 85,000 euros. Okay, so you know better your resources. Pay attention to this and do not make a confusion between the total budget of your proposal and the funding that you are getting for your proposal. Next slide, please. Okay, so before submitting, you will not be able actually to submit unless you have filled in all the mandatory fields. So if you click on review or submit the application and you don't have everything in place, you'll get this message with how many fields you have left unfilled. So you can go, for example, basic information. I have several fields that are not completed. So I click there and I see what I've missed. I can click on them directly and they take me back to the form where I can include the information missing. Once you have all these checked as green, you can submit the application. And here you can see that I went back to one of my submitted applications and I changed a few things and I updated the submission. I get a small confirmation message there that the application was updated successfully. And you can do that as many times as you need. So don't wait to the last day to submit your application. Just do your first draft, submit it, and go back to it if you feel the need to. Next slide. Thank you. So from our experience with cascade funding and financial support to third parties, open calls and applicants, we can tell you that there are several things that you can do better to make sure your proposal is aligned and has good chances of being selected. First of all, the guide for applicants. Pay attention to all the red flags. Be coherent among the sections that you fill in the information. In the case of AMALTEA, choose one challenge and tailor the whole narrative to it, like KPIs, metrics, the resources, the team, everything. Make the TRL storyline explicit, like tell us what is the current status of your solution and your technology. How are you going to take it in the next 9 months, 12 months to TRL 6 and 7? What are your plans to get to this milestone? Show the integration with AMALTEA digital tools. No excuse anymore. You have it very clearly in these slides, which challenge includes which digital tools. So this should be very, very clear, and it should come easy for you to identify it. The pilot site fit, again, we've offered plenty of information on the pilots, but if you still feel there's something specific that you need, reach out to us today or through the help desk. Strengthen the impact section by telling us where you are at present, what is the market that you are reaching for, the competition, how are you different from what's out there already. Prove resources and co-financing. As I explained briefly previously, you have in the implementation part, you have the resource committed section where you can tell us exactly how you plan to do that. Again, the cross-functional team and the gender balance, these are criteria that we are looking at as well in the evaluation. So be very explicit about the people that you are involving in the project if you get selected, and their availability to work with us during the support program. And most of all, read through the application, through your proposal several times and make sure that you keep the budget, the objectives, the work plan coherent, and everything falls into place nicely and clearly for the evaluators. I think these are all our inputs on the application process. I hope it answers some of your questions, and I also hope you have some other questions that we can address now. Agnieszka, if you go to the next slide, I already copied some of the questions that I saw in the Q&A. Okay, you need to refresh it in order to see them. No problem. We'll just read them from the Q&A. And if you have questions that you'd like to address live, you can unmute yourselves and tell us your question. I'll start with the one from Lilia. So Lilia is saying that they are preparing an application for challenge number 5, Renzo. Okay. So, but they believe their solution addresses some components from challenge number 4. Since the call rules that there's only one challenge per application, is it a problem if there is a slight overlap, multifunctionality in our challenge, or it violates the rules of the call? I'm not technical. I don't see I don't understand the technical overlapping. So maybe Nerea and Renzo, you can debate if there is any overlapping there that could be somehow addressed in one proposal, but with a focus on just one challenge.
My comment, Renzo, if you allow me, is
Yeah.
that for the application form, you can put which is the challenge that's much better the approach that you are going to develop. But later in the proposal text, also you can comment that this is something that can use or can address some of the components from other challenge. So this is something that is not a problem. Then when we review the applications, we will check this, but don't worry because okay, there are some challenges that are in some cases connected, or they are doing some part of the process that are connected with each other. So this is something that is not a problem. Put the challenge that suits better what you are doing. Mention the other challenge that can be affected. From my understanding, there is no issue there.
Yeah, exactly. And maybe just to add on, to differentiate also for challenge 4 and 5, challenge 4 is tackling more the overall quality control from uh, the already produced facade with welding, silicon, and everything. But of course, in challenge 5, when you are doing the trajectory online planning, sometimes you also want to check that the quality of the welding is good, but only in a minimal window of time. So in the challenge 4, you have more time to use the camera for the vision system to check the error or whatever you are trying to figure out. And challenge 5 is a very small window. You're checking something like quality of finalities. In case that helps you to define better or to which challenge is better fitting for you, your case.
Thank you both. Lilia, would you like to follow up on that? Thank you. Yeah. So we're taking that this has answered your doubt. Okay. The next question is, it's about a technical error. Thank you for spotting that. The guide and the technical guidelines on the project website, the links go to the same document, the technical guidelines. So you couldn't find the guide for applicants. We are going to correct that. Thank you for, I just checked and you are right. If you go to the guide for applicants, you get the technical guidelines on AMALTEA website. I just copied here, pasted here, sorry, I don't know if it goes to everybody. The link to get directly to the application form, and there you'll find the guide for applicants and the technical guidelines. Okay, the next question comes from Marco. As I understood, the deliverables of challenge 6, Eduardo, are software packages for accurate positioning leveraging sensor fusion. The availability number and positioning of sensors, depth cameras, 3D, LiDAR, CMOS are crucial for this challenge. Who is responsible for deciding which sensors are used and where to position them on the robotic platform? I would also like to know who is responsible for providing simulation environments of the sensorized robotic platform and the test site. It's a long question, Eduardo. Maybe you can go directly to the Q&A and see it.
Yes. Yeah, totally. The amount of sensors that will imply completely different algorithms. So far, the consortium is agreeing on integrating like a 3D LiDAR, an EMUI, and a depth camera for this basic navigation. Ideally, we should aim for like 2 depth cameras. As well, who is responsible for providing simulation environments of the sensorized robotic platforms? This, I don't know if you mean digital simulation environments or physical simulation environments. These digital tools that we plan to develop are meant for on-site construction in not laboratory conditions. We have an issue here that most of the solution has been developed to Tier 3 and 4. So the ideal is to jump from laboratory conditions or like digital, physical, similar models to unaware environments. So In order to try to answer that question, physical simulation environments, ideally, it will be the last step of this challenge. It's free to use any street or unstructured environment. On the digital side, we can build a digital environment to try to assimilate and compare this point cloud sensor fusion. Actually, it's still those questions are still a little bit open and up to be defined. Maybe in the future open call, like in the future meeting. And I don't know exactly how to answer deeper in that question.
Okay. Anyone else would like to add something to this question? Maybe we can address it internally and come up with an answer for Marco before the call ends.
Yep.
So Marco, if you would be so kind to send the question in the help desk, so we have your email address and we can get back to you. Thank you. Eduardo, the challenges 6 and 7 are very popular today. So the
Yeah,
next
I can see.
for you, stabilize the indoor UAV, replace the AGV for challenges 6 and 7. If we meet ROS2, radar plus total station view.
In case of challenge 7, yes, because the software package that could be developed might be cross use among different platforms. In case of challenge 7, no, because we are talking about a ground vehicle and the navigation between aerial and ground vehicles are completely different. Okay, next one as well.
Yeah.
There is a lot.
Hardware challenges like challenges 6 and 7, but I think this one could be addressed by everyone a bit. What is the kind of deliverable expected from the applicant? Will it be just software packages containing the algorithms and GUI tackling the challenge, or also hardware prototypes, sensors, mobile robot should be delivered? So let's start with you, Eduardo, and then have everyone address their own challenge.
Yes. Software 6 is mostly a software challenge, but also requires a lot of hardware. That's why it's classified as well for hardware solution. Of course, the way how to address it might be completely different. One approach could be establishing that the AGV platform should have some sensors allocated, but it's up to you if you want to propose actually like a sensoring rig that integrates the hardware only in one package, so you know that the hardware and software are fully combined and calibrated, and they are completely work no matter where this hardware fusion sensing device is embedded. So really depends on your approach on that side. Regarding challenge number 7, we expect to have some hardware related to it, especially for the human navigation interface, because either you want to go a fully digital software navigation interface that is controlled with a HMI like kind of tablet, or you want to have like more higher hardware implications with some joysticks that is also embedded in your software stack. So in 7, yes, we could resume is 7, yes, we expect hardware. In 6, depends on what solution do you provide.
Thank you, Eduardo. Marcos, could you add something for challenges 1 and 3 regarding the kind of deliverables expected from the applicants?
Yes, sure. So throughout the AMALTEA project, we have an extended digital twin. This is our digital tool that handles like the software, so to say. And the challenge 3 is more about the visualization of the digital tool, so to say, and how to handle it, like how to give the so to say the correct input parameters, which are aligned to the user. And like we know like that like also the challenge 1, which supports the extended digital twin, is running in parallel. So I mean, it has to be developed throughout the project. There might be some integration, but if you do like a hardware challenge, I would suggest to focus more on the hardware itself, and the integration with the software is part of the process of the development, so to say. I hope this helps.
Okay, thank you. Rob, for challenge 2, the expected deliverables, if you could give some examples.
Yeah, I mean, challenge 2 is clearly a software challenge. And I would say, in addition to, of course, the work which needs to go into it, say step-by-step work which needs to be executed, the two big deliverables would be the say iteration generator itself, which we would be building in Grasshopper within Rhino. And then the output itself, so the iterations themselves used for training. So this, which is of course should be a quite large amount of data. So these two deliverables should be achieved.
Thank you. Nerea for challenge 4, or Renzo for challenge 5, whoever is ready. Have you thought of the potential deliverables to be expected?
Nerea, you want to take challenge 4?
The deliverables that will be needed, about the deliverables that we expect to be, yes, I think there will be technical deliverables about the results of the development of the challenge. So I don't really think about this a lot, but yes, we will do it. Yes.
Okay, thank you. Renzo?
For challenge 5, well, this is since we will connect it to a real system, real hardware, we expect that the deliverable or these, so it will contain definitely some components that is software, like the methods or the results for online trajectory planning. But yeah, we have to test and validate everything at the end with the real subsystems with the welding and silicon appliance. So it's combination between software and hardware.
Okay. Thank you, Renzo. Julian, for challenge 8, do you have some estimated deliverables in mind?
Initially, this challenge is more software. The idea is to use the information available for improve the way that we are going to treat this data. So at the end, mainly what we want is like a algorithm or software that give this information or can treat this data. If at the end you consider that hardware components are needed to extract data from materials, so like sensors or this type of things, can be considered as hardware challenge. So take into account that some of these at the end can have these two different approaches. And this is something that is connected to the next question that can a proposal combine a hardware and software on its scope, take into account that hardware solutions almost always are going to have some software connected to them. So hardware is hardware plus software. Software is if you are not going to provide any hardware component as part of your work. This is more or less the difference.
Yes, sorry about the challenge 4. I think just the deliverable will be also a software algorithm that will detect the defects. And if it's something like Julian says, if you are going to use any sensors or the data will be provided by us or something, will be a combination of hardware and software, could be.
Okay, great. Thank you, Nerea. Thank you, Julian. Eduardo, it was specifically for challenges 6 and 7, if you'd like to add something to the potential combination of hardware and software question.
Actually, is what is expected. Like hardware like challenges we expect for sure, like software as well.
Okay, thank you. So this one comes with the example for challenge number 5. In case for hardware application integration with robots, will the challenge owner set available any robots? How can we align with them?
Okay, so
Yeah,
yeah, there will
Q&A.
yeah, at the beginning there will be already some robots that will be available at least for the pilot or for testing validity, and yeah, we can align over what interfaces and APIs are available for this kind of robot system.
Something also that you need to take into account is that, okay, the consortium is going to, in fact, more or less is defined at this moment, the system that are going to be used for the manufacturing pilot and for the installation pilot. So part of the work that you are going to develop in some cases is going to be connected to this equipment. And obviously you are going to have access to them. And the idea is that we collaborate and probably in some moments you come to where we have the equipment and we can be able to check if the activity proposed by the challenge is working properly with the equipment that we are. So part of the activities that you are going to be able to perform is to be in touch with the equipment that is going to be used in the project.
Okay, thank you, everyone. Thank you for posting these questions today. We are going to include both the questions and the answers in a frequently asked question document that is going to be available after this webinar. We wanted to collect some more specific doubts from you through the help desk and this webinar, and to facilitate this document for everyone else after that. If there are any other questions, you can unmute yourselves and just ask the question, or you can. Okay, I have one in the chat just now popping. How can I learn more about the interfaces to the AMALTEA digital tools and core technical infrastructure in order to align properly? Learn more about the AMALTEA, the interfaces to the digital tools.
Yeah, I can't see the question right now.
Right now it's in the chat. It's not in the Q&A.
Sorry. Okay, now I got it. Okay. How can I learn more about the interface to core technical interface? Well, I think we have like a technical documentation within our from our application website, right, Anka? There's all the information included to learn about all the digital tools and also like watch the previous YouTube videos or YouTube video for introducing the AMATEA project. But specifically for the interfaces, so to say, like I mean, it should be like a browser-based platform independent interfaces that we expect from the GUI, right? And it should, and for, I don't know, yeah, I'm not sure if this is about the challenge 3 or
My
more like a
comment,
general question.
my comment, Marcus, is that as this moment, these interfaces are in an ongoing process of definition, try to leave as open as possible this part of the challenge in your application. Then if we consider that your application can be updated better because of the knowing of these interfaces, okay, this is something that we will be able to check. But don't consider that we are going to not accept a challenge or application because the interfaces are not connected with what we are doing, because this is information that has not been defined exactly in the documentation that has been shared as part of the challenge. My proposal is leave a little open, and then we will be able to enter in more detail when we enter in the conversations.
Any other questions that you'd like to address today?
Maybe also to this question, like we will also provide some the infrastructure to work with that to create like the interface. This is only what I want to add.
Thank you, Marcus. We still have some more minutes, so Julian, if you'd like to say some general conclusions on the technical side, and before we leave, we would like to hear a few more seconds. We'll take a few more seconds to hear from you on your challenges in the application process. But before that, Julian, if you'd like to say a few words.
No, at the end, please review the documentation. My understanding is that in the challenge definition and in the pilots, you are going to find useful information about the type of connections that you are going to have with our activities. Please check also what are the main approach that we are trying to develop in this project. That at the end is to improve the way that curtain wall facades are designed, manufactured, and installed and recycled. So take this into account once you submit your proposal, and also take into account that. Until the deadline of the open call application, you can make questions to the panel. So I think that you have some possibilities in the funding box application for the open call to send questions. And please do it if you have any doubt, because our idea or our effort is also to have as much application as possible connected with what we want to do. So please don't worry if you want to make many questions in order to have your proposal better aligned with what we have. Also take into account that the project has just started, so this is the 9th month, so more or less now we have clear what are the equipment that is going to be used, and later this year we are going to start having the possibility to work with all the equipment that now is under deployment in the project. But my main comment is, please, if you have any doubt, share the question with us, and we will try to answer you as soon as possible.
Great. Yes, indeed, we do have the help desk to receive any questions from you. And although this is the main communication channel, whatever details you may need from the technical partners here or others involved in the project, we are going to forward to them all your doubts, and we are getting back to you with a specific answer. Before we leave, we would like to, as I mentioned previously, we are going to have another webinar on the 16th of October, and would like to focus that webinar on specific use cases or specific questions you may have for us. For that scope, we would like to take a couple of seconds from your time, and I don't know if Virgil launched the poll. Is the information on open call to any information on the open call to available? The second open call will be in 2026, and it will depend also on the results of this one, which means that depending on the results we have here, we will configure the challenges, and there will be up to 15, at least up to 15 beneficiaries that we are going to look for in the second open call. If you can share, okay, we already have the poll. So the idea with this short question, with this brief question, is to see which are your pain points for elaborating and submitting a proposal. And this will be the focus of our webinar next time we meet, hopefully with you. We look forward to receiving thank you for taking the time. I think we got quite a few questions, quite a few answers from everyone. We will we hope to see you next time in the webinar. But meanwhile, as mentioned, you have here all the communication channels on the next slide. Agnieszka? Okay. So here you can see all the communication channels that we have open during this application process, and not only the recording of this webinar, along with the recording of the info day that we had in June, will be available on the project website. We strongly recommend you to follow us on LinkedIn as well, because we do provide some news and updates there, especially on the challenges, because we are monitoring the number of applications that we are receiving, including the draft one, and we are going to share some information through the LinkedIn about the challenges that need to be addressed. On Discord, we also have a community, a smart manufacturing community, and an AI community, where you can find answers to particular questions to this open call, to this project, but also you can find other funding opportunities if you are looking for more options. You can write to us by email, as mentioned, and if you scan the QR code here, you'll get directly to the application page, to the online form. You have the guide for applicants there, the technical guidelines, and you can start your application today or at a later date, and always count on us for any type of support that you may need. Again, thank you all for your time today. We look forward to receiving your applications, to seeing your ideas come to life within the AMALTEA project. I'd like to thank to the partners as well for their presentations and for their contributions today.